Hi everyone. We see cycling as a key transport option for Swinburne Uni, which has room for development. It aligns with Swinburne's carbon neutral by 2025 commitment, and we see cycling as a great way to cut emissions. Our approach considers cycling at the local and campus scale. At the local scale, we've identified that the cycle paths nearby are a barrier to entry for many. And on the campus scale, we see an opportunity for upgraded bicycle storage facilities and also improved bicycle access throughout the campus. Our goals are to encourage cycling by reducing risk and reducing emissions by replacing other types of commuting with cycling. As mentioned before, we believe cycling aligns with Swinburne's carbon neutral by 2025 commitment. It is an opportunity to directly reduce the baseline emissions produced by commuting to uni, functionally reducing the amount of carbon offset purchases the university makes. Our analysis spans the local and campus scale. At the local scale, we've used publicly available geospatial data to inform our strategy. BikeSpot was used to identify key areas for a targeted approach. Cycle OSM was used to analyze existing infrastructure. Google Earth Pro was used to look at conditions on the ground and provide imagery. And B-Router was used to analyze the current safest biking routes and where risk arises. So, this is our local map, and this is Swinburne. These are the existing bike paths, ranked from safe green to risky red. This heat map is showing general cycling issues derived from qualitative geospatial data from the BikeSpot 2023 survey. We've isolated car dooring incidents from this data, showing that even with a cycle path, there is inherent risk cycling locally around the campus. These blue dots show places where people have reported feeling unsafe without a bicycle path. We think this is similar to a desire line. People still want to travel these routes, even though there's no path. This has informed our proposed bike network. The light blue shows where we propose upgrades to existing infrastructure, and the dark blue shows our proposed new paths.
We have identified a problematic spot in the road for cyclists, which is highlighted in red. It is the Hawthorne Bridge, which has 2 lanes of traffic alongside 2 lanes of trams. There is no designated cycle lane, so they have to risk their safety by biking on the bridge alongside vehicles travelling at 60 km an hour or getting off and walking the bikes over. We came up with a possible solution to create a separate bridge for cyclists, slightly north of the existing Hawthorne Bridge. It connects to the popular Yarra Trail and links back onto Burwood Road. We use the same green colourway for the bridge that is used in the Footscray to City bike system to keep the visual language consistent. It is important to make these changes to the bridge along with improving the existing cycle lanes and adding new ones, as they will significantly enhance cyclist safety. The risk of car doors opening onto lanes will be reduced, and cyclists will be able to cross the river more efficiently without needing to dismount and walk their bikes. These improvements should also encourage more students and lecturers to cycle to Swinburne University. When people feel confident and secure in the cycling infrastructure, they're more likely to use it.
A comparison of the existing most efficient and safe route, according to B-Router, to the proposed shows both a marked improvement in safety and a modest improvement in terms of efficiency.
Moving on to the campus scale analysis, here are some images of the existing network which currently have no dedicated bicycle circulation. This is a map of Swinburne, also showing no bike paths. We have identified 2 key improvements that can be made: circulation of bicycles and additional covered and secure bike parking. This diagram shows an example of the type of protected bike lanes proposed around the entrances to Swinburne. The cycle paths provide a physical barrier between cyclists and traffic, and improvement to the existing infrastructure. Our proposed upgrades provide a dedicated network of shared pathways to improve bicycle access. Lastly, using a range of prompts, we've used an AI image processor to visualize the best possible modern bicycle facilities.
So, to be a little ambitious and create a moonshot of a 20% increase in cycle traffic, Assuming a few variables, we've calculated a staggering 69 megaton reduction in CO2 emissions, which we think is worth pursuing. Thanks for watching.